Welcome back to the Automation Podcast, the world's number one industrial automation product and technology show, thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience and for tuning back in this week. Now, for those of you who are new to the show, my name is Shawn Tierney of Insights in Automation, and each week I invite a new vendor to come on the show to tell us about their products and technologies. And during their presentation, I play the role of the audience asking questions that I think you, the members of the audience, might have. And given that a quarter of the audience listens to the show, not watches it, but just listens to it, I'll also try to call out anything that I see in the slides of the presentation that I think that you, those of you who are listening, may want to know about. So, with all that said, I want to wish a warm welcome to Shawn Foley for coming back on the show. It's been a little while, but we are glad to have him back on the show. Shawn, how you doing? And welcome back to the Automation Podcast.
Hey Sean, thank you so much for having me back on. It's always an honor to be on your podcast. Really love your content. Been a follower for years, so always great to be back on. I'm doing really well. I'm really excited to be here. Always great to catch up with you.
Well, and I have been trying to stay away from this because I knew we were going to do this podcast. So I'm coming into this knowing nothing about Banner Remote IO, but I'm excited. I've when I first got in this business, that's when I first became aware of Banner some 34 years ago. I've always been a fan of your products, and so I'm excited to learn about what Banner Remote IO is. So let me turn it back to you, and let's learn about this new product.
Thank you so much. Yeah. So today I'm going to be talking a little bit about Banner's remote IO portfolio. So I'm really excited to be a part of the team as a product manager for Banner Remote IO products. And it's something that's fairly new to Banner. Banner's pretty new to this space. Banner's been in the automation world for decades and decades, 50 plus years. And we have a long history of producing solutions for sensors, lighting products, safety solutions. But now we're getting into a new space, and it's really exciting to be a part of it and providing remote I/O solutions for OEMs. Remote I/O has been around for quite a while, and with regards to remote I/O, it's fairly new to the space. But what we do have some really unique solutions that really set us apart, in my opinion, from other manufacturers in the space. So I'm really excited today to talk about the portfolio, talk about some applications and success stories, how we have been able to help some of our valued customers with this technology, some of the things that we could do that really set us apart. Whether it be our form factors, whether it be our advanced programmability, there's a lot of things we could do, and we really like helping and supporting particularly machine builders with their remote I/O solutions with these products. So, without further ado, I'm going to get started. Before diving into the portfolio, I think it's important to look at kind of the evolution when you talk about remote I/O and the concept of decentralized automation, right? It's kind of an evolution that's happened over the years. Here's just a slide for the listeners. If this is an image on the screen showing kind of the evolution of connecting your sensors, connecting your I/O back to a control system, connecting your sensors and I/O back to a PLC. Throughout so many applications and throughout the history of automation, so many machine builders would typically wire their I/O back to their PLC directly. So what that would mean is you'd have your sensors, whether it be a photo eye or another sensor or another lighting product or actuator, going back to your PLC directly. And so what that would mean is typically have to run your cables from your devices back to your input cards and your PLC. And this is still very prevalent in the world of automation, as we all know. Just wiring your sensors directly back to your PLC to input cards. And the challenge with that, though, and I'm sure you've kind of run into this, Sean, is at times that could lead to very large control cabinets. It could lead to lots of different input cards and output cards. It could lead to oftentimes challenging challenges with troubleshooting. If you have lots of devices, lots of sensors, say 128 sensors that you have to wire back to your PLC, each one of those sensors has four wires. That's over 500 opportunities to make a wiring error. And there are challenges with wiring the I/O directly. Um, And then we kind of move to the next thing, which a lot of machine builders have been using passive junction blocks. So these blocks that have, instead of sensors having cables running directly back to the PLC, they're using passive junction blocks with a typically a bulky home run connector going back to their PLC. Very similar to directly wiring I/O, but just another method. And then we start moving into network I/O blocks. So having instead of having to wire your sensors back directly to your PLC, you would land it on a network I/O block and just have an Ethernet cord set going back to your PLC. And these network blocks typically have things like analog inputs or discrete inputs. Going further, we're looking at talking about IO Link and using IO Link masters. This is where we could really expand on the number of devices you could use, and there's many advantages to IO Link. And if you actually, we did a podcast not too long ago, Shawn, on the advantages of using IO Link networks. But it's another great thing that a lot of OEMs have standardized on, um, for bringing back IO to their control systems. And really excited to be a part of the team at Banner that have brought a lot of products to the market for using discrete hubs, IO link masters, IO link converters, for bringing back not just discrete IO to a control system, but analog IO and other different types of signals back to a PLC. So Banner's been very active in this space for the last 2 years in working on our IO link solutions. So IO-Link has been used quite a lot, and the advantages are immense with using IO-Link, as you've probably seen, Shawn. And then we move to kind of something that's very unique to Banner, and that's be using Modbus RTU networks to bring back IO back to your PLC. So in addition to IO link converters, IO link hubs for bringing back discrete PNP signals or analog signals, we've also got a Modbus variety. And so when you look at Modbus RCU versus IO link networks, Modbus also has some unique advantages. IO link, it's point to point. So if you have an IO link master, you could only connect one IO link device to each port on your IO link master. So you have an IO-Link master port, you could connect one IO-Link device to it. Um, the nice thing with that is, though, you could use hubs. So you could have an IO-Link hub, which is an IO-Link device, and have 16 discrete sensors brought back to your IO-Link master. When you look at Modbus, however, and you'd use a Modbus controller instead of an IO-Link master, like what we show here, you could have one of our DXM controllers with 5 Modbus RTU ports. The nice thing with this topology, though, is the ability to tee into large numbers of these Modbus converters or Modbus hubs for bringing back I/O to a PLC. So we have converters and hubs in both the Modbus variety and the IO-Link variety. So it allows us to really go into a machine builder and mix and match Modbus and RTU Modbus RTU and IO-Link networks for price and performance. Sometimes it's about finding what's the right formula for bringing back IO to your control system. The nice thing is the different form factors too, is you get to mix and match housings. We call it right sizing your IO for the application, because Banner has both 1 port, 2 port, 3 port, 4 port, and 8 port converter options or hub options for converting these legacy signals like analog and discrete over to IO-Link or Modbus RTU. Does that kind of make sense, Shawn, from your perspective? And I know you've probably seen the evolution, um, and there's still many customers out there who use directly wired IO in a lot of their applications, and moving to remote IO system. Have you kind of seen some of these evolutions? And we're still seeing them, of course, but do you see a lot of this OEMs and machine builders transitioning to these networks as opposed to direct wire IO?
Yeah, I do. And I think, there's, different applications. So IO-Link is great for some applications, especially when you need more than just the analog or digital signal. If you need some of the intelligence of that sensor, right? And sensors are just getting smarter and smarter and smarter. But In some cases, especially for the end user, the Modbus side is great because, we're talking 485, we're talking 4,000 feet, we're talking daisy chaining, we're talking simple, long distances, not a bunch of hubs and switches, so Modbus RTU has always been a favorite for those type of, longer applications, not so much for an OEM per se, but for maybe an end user. And I think, so definitely there's a difference here in who's using what, but I think we're seeing a lot less direct wired IO unless it's a very, very small machine. Then we're seeing a lot of direct IO. But again, if they need the intelligence out of the sensor, maybe they have an IO link module in the PLC chassis instead of, just a standard digital input module, right? So
Exactly.
definitely I'm right in tune with what you're showing here.
Absolutely. And I think when you talk about some of the advantages I've seen, with remote IO, and remote IO has been around for a while, but a lot of things I like to talk to are the flexibility. So remote IO allows for distributed control systems. So that kind of enables flexibility in the placement of IO blocks throughout the facility. Another big one is reduced wiring. So simply put, I think you've probably seen this a lot, is it just decreases the amount of wiring needed. As IO blocks can be placed closer to the field devices and your sensors, this reduces your installation times, your maintenance costs, your wiring mistakes. And a key thing I've seen many OEMs see as an advantage when they're transitioning to remote IO is the standardization on easy to install, cost effective, and frankly, readily available M12 connectivity in tons of applications. Um, and reduced wiring is huge. And would you see reduced wiring as kind of one of the big drivers? A lot of kind of OEMs and machine builders are transitioning to this remote IO strategy.
Yeah, and I think I need to say this for some of the old timers on here. We're talking when we say the remote I/O, we mean distributed I/O. When we say distributed I/O, we're talking remote I/O. Those two words are used interchangeably. I know some people remember the old networks that came out in the late 70s, early 80s that were we're not talking about that. We're talking about modern day distributed remote I/O that you wire your devices into and then goes back to your control system. So I thought I'd just say that because I know old timers like me, we used to always get a little bit like, well, that product's not available on remote I/O. We're talking about distributed I/O, remote I/O. So in any case, yeah, that's and it's almost a matter of fact, a lot of the major PLC vendors are telling me that in many instances, people are just buying the PLC, putting it in its own little rack, and they're using 100% distributed remote I/O, right? They're not doing any local chassis I/O, and a lot of times that's because the local chassis I/O is more expensive than the distributed I/O or the remote I/O, right? So, which is to me is a trend that I was surprised about. But here's another trend that the major manufacturers are telling us. What you guys are offering here is the trend. People are buying this machine mounted type of IO like you're showing in these pictures. That's becoming the norm. People are starting to get away, and this surprised me. But OEMs and other companies in this space, they're getting away from installing an enclosure and then sticking traditional, IP20, distributed I/O in it, like I don't know, whether it's Allen Bradley or Siemens or whoever, right? Schneider or whoever. They're getting away from that. They're putting everything on the machine, and that surprised me. But that trend is borne out by the fact that if you just talk to the major vendors, that's what they're seeing, a move to this type of, you know, um, and I haven't seen all the slides, but I'm assuming this is not IP20, just dust tight products that you're offering.
Exactly. These are gonna be IP67, IP68. And yeah, I totally agree with you on the trends we're seeing with these products for sure. With a lot of these machine builders and manufacturers moving to kind of the distributed and remote IO solutions. I think also if you look at in terms of PLC wiring and wiring sensors and IO to your PLC, being able to simplify wiring and reduce wiring, it really also means significantly faster installation times for a lot of machine
Oh
builders.
yeah.
And another thing I've run into is modularity. So, if say you're a machine builder and you're building a machine for an end user, and you're building it, and you're first building it in your factory, and you have to ship it. when they're first building the prototypes and they're building the machines in-house, they have to disassemble it and ship it.
Hmm.
The nice thing about connectorized connectivity is the quick disassembly and reassembly of these machines. If they're hardwired back to the PLC input cards, it means you have to unscrew every screw terminal to disassemble it. And I think the modularity approach is important too. Um, in terms of other things I've seen is the scalability. They're easily expandable. I'm sure you've kind of seen this too, Shawn, is sometimes they maybe sensors needed to be added to a machine and you know don't want to dive into the control cabinet, but they could just add new sensors to these blocks and bring in IO and just add new sensors without increasing the size of their control cabinet. And that's a big thing I think too. And I keep talking on a lot of the advantages, but the improved reliability, by minimizing the distance between sensors and actuators in the control system, these remote IO systems can also improve signal integrity. So if you're using analog sensors and you're converting it over to um, IO link or to a Modbus RTU or serial network, um, you're going to be able to eliminate a lot of the shielded cord sets that are sometimes more expensive. Well, we know they're typically more expensive than standard wiring, but also can sometimes be difficult to source. So I've kind of seen a lot of that. And um, when we kind of look at, um, we've got the two different varieties, and we'll talk a little bit more about the products. But a question I often get is, Shawn, these two solutions, you got this portfolio of products for getting data to your control systems um, via both, say, Modbus RTU or IO Link. We've got the two varieties. People always say it's like, oh, almost like Lego building blocks for right sizing your IO for the application. I really kind of like that, the way they describe it. But when to use one versus the other? Well, you're looking at Modbus RTU versus IO Link. So both, you'll be able to use standard M12 cables, unshielded M12 cables. Because as you're converting these signals over to both, say, IO Link or to Modbus, it's going to make those signals immune to noise. If you look at Modbus versus IO Link, there's a few important differentiators. One, if you're, say, connecting a Modbus server device, such as a Modbus hub or converter, to a Modbus client controller, you have the ability to connect, like you said, Shawn, 4,000 feet of range. So you could
Hmm.
have your IO very far away from your control system, up to 4,000 feet. IO Link is you're going to have that 20 meters. That's part of the IO Link spec from your IO Link master to your IO Link device. With Modbus, there's no real data transmission limitation, and with IO Link, there is going to be a process data limited to 32 bytes in and 32 bytes out. It's typically not a an issue. Um, Modbus is an open protocol, so each that is means that each manufacturer chooses data and communication settings for each device. With IO Link, it's part of this consortium of over 500 or 400 different manufacturers. So you could connect anyone's IO Link device and it should work with everyone's IO Link masters. And that's a huge advantage of IO Link, in addition to some many more. Um, but when you look at another thing with Modbus, if you have a Modbus controller with Modbus client ports, you could have up to over 32 devices on each of those client ports going back to one IP address for bringing the data back to your PLC. And so by using some of these hubs, we've seen applications where machine builders and OEMs have been really able to consolidate the amount of IP addresses and have a lot of IO going back to their PLC using Modbus RTU as the kind of conduit for getting that data. It kind of enables more devices than kind of ever before with by using these kind of Modbus client ports to bring back a lot of IO to a PLC. So with IO Link, it's point to point. So you could have IO Link devices such as sensors, IO Link hubs, IO Link converters connected on each port of your IO Link master and bringing back the data. Um, There is, I often like to advise when people are, where do I use one versus the other? Um, it's to kind of, look at the system, look at the topology, and look at the application requirements to really figure out what's the right mix and match of products for optimum price, performance, reliability. Speed becomes an issue, can become a factor as well in making those decisions. How far away your I/O is to your PLC. I think questions like this, but this is a slide that just kind of goes through. We've got these two varieties for bringing back the data, and kind of when to use one versus the other, and it's important to kind of figure out what's the best fit for the application early on as you're planning the system. But the nice thing is, if you ever have any questions on this and you want to optimize your system design, feel free to reach out to the Banner support team. We've got a really great application engineering team group here, and we've got a lot of very advanced application engineers who are really have a great level of knowledge in this area. When to use one versus the other. Um,
I want to jump in there for a second. I know a lot of people may be thinking, I stopped using Modbus RTU because, we just needed so much data through it. And we're not talking about having 50 PLCs send thousands of integers to each other every minute, right? That's not what we're talking about. This is not to replace your industrial Ethernet. What we're talking about is a way to use Modbus RTU to talk to a bunch of field I/O, which
yeah.
is not tens of thousands of integers, right? So I just want to throw that out there because I know a lot of people think, oh, Modbus RTU, it's kind of like data sidewalk, right? It's not designed for huge amounts of data that go between controllers. And yes, that is true. But here we're talking about just imagine, how many sensors can you get in 100 words of data, right? I mean,
Yeah.
you can get a whole bunch. You can get probably more than you'll ever need on your machine, on a single machine. So it's for these type of applications, it is just really sweet. But again, IO Link has that ability to get that additional, if you have everything close by, you don't need that 4,000 feet. There's so much these intelligent sensors from Banner and other companies have so much more information you can get out of them. And you can even configure them, right? Like I know Banner has these great illuminated beacons and light stacks and all these things that you can actually configure them right across the IO link, right? So you're
Yeah.
not down there with dip switches and trying to, you don't even have to get into that. You can do that all via the software. So those are some of the advantages and some of the things that I think about when as I was looking at your slide. And I'll turn it back to you, Sean.
That's such a great point. And talking on the IO link, I know we had a discussion on another podcast and the advantages. I believe it's called the 8 advantages of IO link, and I really enjoyed
Yep.
chatting with you about those. And yeah, like you said, access to sensor and device level data with IO link is huge. Being
Yeah.
able to know when a sensor is overheating or a lens is starting to get dirty on a photo eye, or maybe you want to change the configuration remotely on your sensor if you're running a different product, like recipe
Hmm.
control,
Yeah.
dynamically changing sensor settings from the PLC. If that's something where you want access to sensor level data and device level data, IO-Link would be your commonly the route to go.
I was gonna say back in the 90s, we had to go out into the field and read self-teach these sensors every time we ran a new product, and that was not efficient. So being
Yeah,
able to do that in, based on recipes, like you said, night and day difference than having to go out there. I mean, in some cases, the plant would buy multiple sensors, and you just use, sensor one for this product, sensor two for that product, because they couldn't go out there and redo the self-teach every time. So
yeah.
that's a very good point. Back to you, Sean.
Yeah, that's so true. And with setting device configuration, so many devices have the push buttons, and they have all with that, it's kind of almost virtually infinite sensor configuration possibilities, which is great. But also, what if someone, say a forklift driver, runs over your photo eye or your sensor, and it's been in operation for 3 or 4 years, and you have to reconfigure it? Uh, Before IO Link, you would typically have to go and online, or if you have the hard copy, get the manual and play around with the push buttons on the sensor to the device, hope it works, plug it back in, and kind of hope for the best. With IO Link, you could rest assured, using data storage mode in the IO Link master, it'll automatically upload the sensor configuration for you. So another really sweet advantage of IO Link is that the ability to do backup and restore mode or data storage mode for device configuration. So you plug it
Yeah.
in, set it and forget it, and it's a huge advantage of IO Link.
Yes, it is. Absolutely.
Um, so I'm going to talk a little bit more about some of the solutions Banner has in this space. I'm really excited about when you look at our multi-protocol Ethernet blocks, and using those two ways of getting the data, both that Modbus and IO Link. Here's kind of our selection of multi-protocol Ethernet products. We've got the DXM R90X1. And so what is this product? It's really the consolidator for Modbus networks like we've been talking about. So being able to use the 5 Modbus client ports on the DXMR90 to talk to these Modbus server devices, Modbus converters, Modbus hubs for accessing the data from these legacy sensor signals and bringing it back over Ethernet IP, Modbus TCP, or Profinet back to a control system to send the data where it needs to go. This is the control that we have for that area. We've also got our 4-port IO Link master with multi-protocol interface. It's the DXMR94K. And so this is going to have, instead of the 4 Modbus client ports at the bottom, it actually has 4 IO Link master ports at the bottom there. And what it also has is a 5th port that you see right here, and it's not IO Link, it's Modbus RTU. So that opens up some interesting possibilities if you have a Modbus, if you want to mix and match IO Link and Modbus to optimize your application, there's some really cool things you could do with this Modbus RTU port on this IO Link master. Um, then we've got our 8-port IO Link master. So this is an 8-port variety, 8 IO Link master ports. Again, just like the other controllers, it's multi-protocol, and it's just one part number. So Ethernet IP, Modbus TCP, and Profinet. Um, and one really cool thing that I really like working with customers on, Shawn, is what we could do with custom programming with these devices. These DXM controllers have object-oriented programming, and we have things like action rules that allow you to program logic locally in the controller. And in many applications, we've been the possibility to almost eliminate a PLC entirely for smaller applications. So we've seen applications on small machine builds where people have used our controllers, our IO-Link Masters or our DXMR90 X1 Modbus controller to replace um, industrial PCs or even potentially replace PLCs entirely. And so that's where it gets really exciting when you're chatting with customers on what we could do with the advanced programmability on these. It's really kind of what sets apart in a lot of these applications is the fact that we could solve um, some of these smaller applications and replace the PLC entirely. Because sometimes PLCs can be really quite expensive. And
And overkill for
yeah,
some
and
very
overkill.
small
Yeah,
applications. I mean, if you have, I like this. I mean, like having the ability to put the logic in the device. I know other vendors have had this in the past, and then they stopped doing it. And I think that's a mistake because there are so many applications where you're only using 3 or 4 I/O, and why have to buy a PLC unless you just have an extra one lying around? But and then you have to buy the software, and you have to maintain the software, and it's
yeah,
for tiny applications, it's awesome having the logic in the device, and I think that's very cool. And I'm just going to go on an aside here, back up for a second. I mean, regular listeners know I've been bragging about these devices because when you buy like the X1 and 4K, I know for sure when you buy those, it does Modbus TCP, Ethernet IP, and Profinet, right? You can choose. You don't have to buy like there's not an X1 Modbus TCP and an X1 TCP IP and an X1 Profinet version. It's one unit that has the ability to talk whichever one you need, which I think is so cool. Am I right about that? I'm not making that up, right?
exactly right. Yeah, it's multi-protocol, and so we order one part number, it'll communicate all those different protocols: Ethernet IP, Modbus, TCP, and Profinet for all these different models, which is really great.
Yeah, that I mean, that pretty much gets 90% of all the PLCs on the market speak one of those. Some of them speak all of them, but most PLCs in the world speak one of those natively. And so you can just standardize on this block and use it with any, if your customer specing this or that, you can use the same product.
Yeah. And it's you bring up such a good point on the PLC sometimes being overkill. And I was chatting with Mike Black. He's one of the manufacturing engineers at Banner. He actually used these controllers on one of his machine builds for dispensing adhesives to
Mhm.
actually build Banner product. And so he's using one of these controllers, and what
Nice.
he's looking at using initially a Becca or an IPC. Um, and it had a cost, so he was looking initially at that. And when we saw that what we could do with the object-oriented programming within these controllers, he was able to replace that. He also talked to me about the importance of in the application reducing costs by eliminating the control cabinet entirely.
Mhm.
And he said there's costs associated with that. You have to deal with costs with UL certifications. It has to be certified, and being able to replace the PLC or an IPC in certain cases, um, you could save a lot of costs in some of these applications for smaller applications, certainly.
I sat through a presentation that a high volume OEM did. It was about 20 years ago now. And he was talking about this machine mount IO. And he says, look, I know everybody thinks because the IO is IP67, it's more expensive and you're going to buy the the M12 connectors and cables and cord sets. And, it's just much more expensive than buying an enclosure and throwing a rack of IO in it. He says, in reality, it's not because you save, like to your point right now, it really isn't more expensive, especially when you start including the cost to wire up that panel. Then it becomes much less expensive. But he says that's not the reason he liked it so much. He liked it because they could put a machine together so very quickly because everything is quick disconnects. He said that is a thing that a lot of OEMs don't think about is time it takes to turn around and build, right? So
Yeah,
if you're going to wire up, let's say 300 IO points to the classic terminal blocks, that is time consuming. I just for my training courses picked up a bunch of stuff, and so I could expand my courses, and I was wiring up all these IO cards to test them out, and I can attest to it even after I was doing the seventh, eighth, ninth module, it still takes a long time to wire up 16 IO points, right? So
yeah,
just the speed, how much faster you can turn around your machines by click, 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 and go. So back to you, Sean.
100%. That's a great point. It saves so much time, and as we all know, time is money in a lot of these
Oh yeah,
cases. And I've also seen with diagnostics the side of I remember stories where machine would be down and they're trying to figure out what's going on, and it just turns out
yeah,
as something as simple as a screw terminal. And sometimes
been
it's
there.
you've been in a case where you see a case where they just didn't tighten down the screw enough, and
Yep.
that could help be eliminated with the connectivity with remote IO for sure.
I'm raising my hand on that because I've driven for 5 hours just for that, just to solve that problem. Oh,
Yeah,
you didn't screw down the screw all the way. I've been in that position, so that is so
yeah,
true. That is so
it
true.
happens. It happens for sure. Um, and so when you look at some of these applications and using this is a slide that kind of shows how you could use Modbus with that Modbus controller, the DXM or 90X1. This is where we talk about right sizing our I/O. So we've got these different hubs and converters, and you kind of see them at the bottom. Being able to connect discrete I/O to these hubs and these converters and analog I/O. And so we've got different models, whether you're using 4 to 20, 0 to 10 volt signals, NPN, PNP signals. We even got serial or Modbus RTU IO Link masters. So it allows us to connect IO Link devices onto a Modbus RTU network and then back to the DXM R90 industrial controller. And from there, send it to the PLC. So it allows us to use and combine 1, 2, 4, and 8 port devices and take advantage of things like being able to connect large quantities of devices to one client port on the DXMR90 industrial controller, but also run long distances. And we've even seen cases where people are using some of our serial data radios, such as the R70 that you see right here on one of those client ports, to send data back from a remote island of IO from a server radio. So this is a client radio, and you could have a server radio across your factory, communicating data back that way as well. So really great bundle of products. And the nice thing is these converters are brand agnostic. So it doesn't necessarily mean you have to use banner sensors. These devices will work with other manufacturers' devices, which is a nice advantage.
Well, and
Uh,
this is really good too. If you're an OEM, you have a larger machine, you don't want to run all your M12s all the way back to let's say you have a central PLC cabinet. So being able to put, the drop down to Modbus, which is just one run, down to a block with a bunch of IO link inputs, you can actually put those IO link blocks or those IO blocks around the machine and then run Modbus back to your main controller, right? So that makes a
exactly.
lot of sense. And you're not, some of these machines just they're not so compact where everything can run right back to the PLC. So, God, back to you, Sean.
That's a great point, Sean. Great insight there on that. And I think too, with just the amount of devices you could take back, it is important. When you're talking about adding more devices, it's where you just start having the conversation though as you get in these larger networks and you're using these devices, is the importance of speed, and that there's
Hmm.
things like too, if you get into very large networks, is the perhaps might need to be a need for power injection. Rare, but sometimes that becomes a thing where, if you have a lot of devices on one of these networks, um, being able to use power injection. That's for very large networks, though. We don't run into that too much, but important to keep note of. Um, but then we look at right sizing your IO with IO Link, and here's kind of a slide that shows our 8-port IO Link master, and we've got some of our um, 1, 2, 4, and 8-port hubs connected. So we've got an 8-port hub here. This is our so this IO Link master is a DXM R110 8K IO Link master, and then we've got our R95C 8B22-KQ. It's a 8-port discrete input and output hub. So a nice thing with banners hubs are that they're bimodal. So what that means is they could do PNP or NPN. Doesn't
Nice.
matter which signal. So it's one part number. You could do NPN or PNP signals. We've also got single port varieties. So if you have analog or discrete signals that you want to bring back to your control system, you just have one. You could use one of these single port converters or hubs. We've got 2-port varieties as well. And we've also got 4-port. So we've got a discrete hub for taking back discrete IO. It's a 4-port, but we call it right sizing your IO, and it allows you to kind of mix and match based on your needs. Sometimes, if you just want to really keep it simple, you might just want to use a couple of our S15C single port um, hubs and connect one device. Sometimes it makes sense though to have more the expandability aspect. If you maybe don't need them right now, but in the future you might decide to add more I/O, it might make sense to have one of these 8-port hub options or 4-port hub options. So it allows you to really quickly scale up the system, but it gives you the flexibility in bringing back and mixing and matching, almost like Lego pieces for optimizing your system. And you talk about some of the advantages of these devices. And one, when people look at them compared to some of the other manufacturers in the space, is the unique form factor of these. The side profile of these devices means typically cable bend radius is sometimes an issue with the top exit block IO style. These are side exit. So what that means is in a lot of cases,
Oh,
cable bend
yes.
radius is less prevalent. It is less of an issue in a lot of the instances where they use the side profile exit style with these devices.
Yeah, no, I see exactly what you're saying there. So you can mount this right on the machine, and everything exits around the perimeter of it, not off the face of it. And so
Yeah,
that reduces. I want to ask you a question. I hate to keep throwing these out at you, but
that's
I'm
great.
looking at the R45C analog. Looks like two analog. Is that are both ports analog in or analog out?
Exactly. So that's an important thing with some of these converters. We have models that allow you to take in analog inputs, either 0 to 10 or 4 to 20, or drive analog outputs. And we've got this in both IO Link and Modbus RTU hubs.
Nice.
So if you want to take in an analog signal, well, 4 to 20 or 0 to 10, you could use those two ports for that. Or if you want to drive, two analog outputs, you could do that as well. So it gives you the flexibility, and that's a great one. It's almost like a kind of Swiss Army knife converter for analog I/O, and so you could do both. So in a lot of cases, I've seen it with some valve applications where a customer is standardizing on IO link, but they still have non-IO link devices
Hmm.
in the field that take in a 0 to 10 volt signal to control the valve or control or motor driven roller, for example. And they want to control that. Um, and they have an IO link system, but they still have these devices, out there that are still
Hmm.
dependent on analog. It's
Yeah,
a great solution for that.
nice.
Good catch. I'm glad you brought that up. I forgot to mention that. And so here are different IO link hub options that I was kind of highlighting a little bit in that slide. We've got, like I said before, the one port options. So the ability to take in NPN or PNP signals or 4 to 20 signals in a single port option. These little S15 converters that you're seeing here, they're, if you look at them for the listening audience, they're about the size of a AA battery, just for reference, and they just have M12 connectors. So it's all IP67 connectorized. Then we move into our R45C, and just so everyone knows, the S15C, it's a 15 millimeter diameter. The R45C converters are based on the size is 45 millimeters. So a lot of the
Okay.
part numbers, it kind of make it's based on the size of the product. But if we look at our R45Cs, this is a model that takes in 4 to 20 or 0 to 10 volt signals and converts it over to, or sorry, it's an IO link, takes in an IO link signal, converts it to analog. So if you want to drive an analog output from your IO link master, these are great converters. And then we get into the dual analog, which is it could do either or. So it could take in analog input on those two ports, or could drive two analog outputs on those ports on on an IO-Link network.
And there it says it right there, analog mirroring. So if you want to bring it into the control system but mirror it back out, you could
Yeah,
bring it in and then mirror it right back out on that device and also tap off of it to bring it back to the PLC.
exactly. Yeah, and I've got a slide that highlights this is a really cool one for retrofitting
Hmm.
applications where there's an existing analog signal and they want to still have that analog signal go back to their PLC, but they want to control a light on the P that also has a PFM output
Hmm.
on one of these ports. So it's a really unique. Um, Very cool. It's probably one of my favorite converters that we offer, or hubs that we offer. It's this model here. And we've got our 4 port discrete hub that could do NPN or PNP signals, and we've got our R95C 8 port hubs. Um, and a lot of our discrete I/O hubs, I could talk a long time about it. I don't want to spend too much time on the part numbers, but the fact that we could do actually logic within the hubs. I'm going to talk about a little bit about that in a little bit on what we could do with logic residing directly in those discrete hubs that you see there. And so here's kind of a slide, Shawn, that highlights the kind of building block analogy of this. The being able to mix and match these different products can be really powerful in a lot of these applications if you're using Modbus or IO-Link. Here you see is you have our DXM R94K IO-Link master. Whoops. And what this has is the 4 IO-Link ports there at the bottom. But then what's unique is it has that Modbus RTU port. So you could use these Modbus hubs that you see on that Modbus chain, as well as those 4 IO-Link master ports. You could use those hubs on those ports. So it allows you to kind of mix and match in a lot of these applications um, to kind of optimize your system. The key thing here is flexibility, and it's really excellent way to kind of mix and match. And certainly, you could just use IO-Link, you could use just Modbus, or you can mix and match in this particular case. Does that kind of make sense of this image, Sean?
Yeah, I definitely see if you're going to go more than 60 feet, that's great because now you don't have to get another industrial Ethernet device. You could just do the Modbus RTU over to the other side of the machine and pick up the rest of your signals.
That's so true. It's great for overcoming certain distance limitations with
Hmm.
IO-Link. 'Cause, yeah, with IO-Link, there's the 20 meters is the max, as you
Hmm.
can see on this slide here, from going from an IO-Link master to an IO-Link device. So here's kind of a slide that highlights just an image of the S15C. Again, about the size of a AA battery. We've got many different models to choose from. Kind of like a Swiss Army knife. You could pick and mix and match these converters to solve a lot of these applications. Then we go into our R45Cs. So these are great if you want to drive a analog output and you're standardizing an IO link, but you still have devices. Maybe it's pneumatic actuator, like this GIF shows, that's controlled by a 4 to 20 signal. These are very common. And then you go into the other converters that we offer, the dual analog. So it could do both. So you could do analog inputs or outputs on either of those ports. So a great flexible option, um, if you want to bring back analog signals and convert to IO-Link or drive analog outputs from your IO-Link master. So that same converter, I'm so glad that you mentioned that, Shawn, because it's a really cool feature of this particular um, dual analog IO-Link converter. So what we could actually do is what's called port mirroring on this device. So what this means is we could actually take in an analog input on one of those ports on the IO-Link um, hub or converter in this case, and you could actually mirror that to another port. So we're taking in an analog 4 to 20 or 0 to 10, and we're mirroring it. And what we could actually configure this converter to have is it has IO-Link on that male port, but it also has a PFM pin, so pulse frequency modulation. And so what's the kind of big deal with this is, well, now we can actually go in to existing analog sensors, whether it be a T30R radar sensor, whether it's a pressure sensor, flow sensor, a sensor with a 4 to 20 or 0 to 10 volt signal already communicating to a PLC. Well, what we could do now is we could install one of these converters, still allow that 4 to 20 signal to go back to the PLC, so we're not interrupting that at all. But now we get that beautiful PFM output to control a light and add a visual factory element to almost any analog application without disrupting an existing control system. This is kind of more of an end user focus. So if you have an existing analog signal, but it's another cool feature of our converters with some of the programmability, what you could do with solving some cool applications, improving a visual factory element in a lot of these, maybe a tank level application or a flow application. You want to show personnel in the factory, my tank level's getting too low, my pressure's maybe getting too high, or my flow's getting a little too low. And seeing kind of a red, yellow, green for visual factory element to some of these applications with some of Banner's lighting products, which I think are really, really great. We've also got analog IO-Link hubs. So if you have, and this is the model for taking in multiple analog signals. So this is an 8-port analog input IO-Link hub. Very similar in form factor to the discrete hubs. But if you look at this hub, we've got now the ability to take in 0 to 10 or 4 to 20 signals. So it could do either 0 to 10 or 4 to 20 signals on one model. It's configurable in that sense. So it's just one model number that could do 0 to 10 or 4 to 20 signals. Another great one if you're using a lot of analog IO. And here's just a slide that highlights the different form factors of some of our discrete IO link hubs. And if you look at discrete IO, it's so common out there in so many different machine builder applications. And some of the differentiators of Banner with regards to IO link is what we could do with some of our, and Modbus is our discrete hubs. We could do logic within the hubs themselves. So what that means is we could do what's called port mirroring. So being able to mirror a discrete sensor input to the hub and mirror it as an output to another port on the hub. But we could also do on-off delays, one-shots, pulse stretchers. So you could configure the hub to do all these little, almost like smart relay applications
Mhm.
right there locally in the hub. There's no other real hub manufacturer that could do some of the things we could do with advanced programmability. So what that means is there's some cases where it's almost used as a smart relay. Um, and people are using these devices with counts, with timers. They're turning on an input on one port, waiting 5 seconds to turn on an output on another port. Being able to solve kind of these unique standalone applications with some of these hubs, again, for really simple applications, this could be a great problem solver. You could actually program the logic right in the IO-Link hub, which is really, really cool. And what you do is you just use it like an IO-Link sensor. You configure the hub to do these unique standalone applications. Another differentiator with the hubs is the 4 amp power. So on pins 1 and 3 on our IO-Link hubs, it shares the 4 amps on the M12 connector. That's the limit, but it shares the 4 amps as needed. So if you have a lot of devices connected to an 8-port hub, some manufacturers out there with hubs, they have a half amp limitation on the amount of power you could share to the device that's connected. In some cases, maybe you have a device connected on your discrete hub that consumes a lot of current. The nice thing is the 4 amps with banners hubs is shared as needed on pins 1 and 3. The power traces are parallel wired to each port. And so that's a big advantage if maybe you have some devices that don't consume much current at all on a hub, but then you have one device that consumes a lot of current. Maybe it's a light or another product. It's a big advantage for that. It's kind of in some cases it could be a really big deal because then you don't have to use power injection, which is an important differentiator to know. And then you look at discrete hubs as well, like I mentioned before. The ability to do NPN or PNP is big. We've got a lot of videos on just covering that, what we could do with unique programming. So I encourage you to check out some of our demo videos that kind of goes over some of the unique programming features of our discrete hubs. It's pretty cool what we can do. And this is kind of a slide, Sean, that shows the stackability of
Oh,
our form factor. We talk about uh, in some machine builds, space is at real estate is at a premium. They don't have a lot of real estate to install devices, and sometimes in small machines or even large machines, they're really tightly packed together, and the banner's form factor really uh, becomes a big advantage in some of these applications where you have the side profile, so the cable bend radius is less of an issue, but also the stackability, being able to stack these on top of each other is kind of a really cool advantage. And I'm sure you've kind of seen some of those applications where you know everything's so tightly packed
mhm, yep.
and space is constrained, and so that's important to note is the fact that banners devices are stackable.
Yeah, I just want to say this for the audio audience. We're not stacking them like one on top of another directly. This bracket offsets it a little bit so that you can still get to all the connections even if you stack them. So just for the audio audience, there's a bracket here that when you're stacking one on top of another, it offsets it a little bit so all the so you can get to all the individual ports. So I just wanted to throw that out there. Back to you, Sean.
Thanks for their reminder of that, John. That's a great point, and also the fact that you could it offsets it too, so you could see the LEDs of the block that's underneath. So you still get the
Oh,
IO
okay.
LEDs, which is kind of cool there too, if you're using two to stack. Here's a slide that highlights some of our Modbus RTU blocks. A very similar portfolio to the IO-Link product family, except in a Modbus variety. So if you ever have any questions on these models, I highly encourage you to go to the Banner Engineering Remote IO page on the website, but very similar in portfolio. Um, Similar with Modbus, it allows you to kind of right size your IO with, 1, 2, 4, and 8-port hubs or serial IO-Link masters, which I kind of highlighted before. We've got serial IO-Link masters like this one here that have a Modbus RTU communication. So you could bring in IO-Link devices on that network as well. We talk about overcoming distance limitations. So using multiple IO-Link masters. We've seen certain cases where they want to overcome certain distance limitations. You could use the advantage of Modbus and IO-Link to run long distances between your serial IO-Link masters, such as our 4-port and our 2-port serial IO-Link master, to bring back data and have a very long cable length going back to a Modbus client. So that allows you to kind of mix and match the best of both worlds in this case of IO-Link and Modbus. So you're able to do things like this. You could use our serial IO-Link masters. This is a valve bank application where they wanted to connect large quantities of hubs. So they used our serial IO-Link master, which has a Modbus RTU communication. And this image for the listening audience, it almost looks like a spider web of IO, but it's essentially showing a IO-Link master going back to the Modbus client. And then on the IO-Link master, you have 4 hubs that are connected to each IO-Link master. but allows you to bring back large quantities of discrete I/O. And in this application, they wanted to do that, but have it on one IP address on the DXM or 90X1 industrial controller, which has the four or five Modbus R2 client ports. So a really cool thing is we've got both serial IO-Link masters, Modbus RTU, and then multi-protocol Ethernet IO-Link masters. So we've got a lot of things we could do with flexibility, and that's very important. Again, on the DXMR94K, being able to use that Modbus RTU port to tee into these serial IO-Link masters. So if you want to connect more IO-Link devices, you have the four IO-Link master ports there that you could connect to hubs and sensors. But you also got the Modbus RTU port to really expand on the number of IO-Link devices you want to connect back to your PLC. Again, on some cases where you want to run maybe longer distances to your sensors, it could be a great way to overcome those distance limitations. Does that kind of make sense, John, on this slide?
Oh, absolutely.
And then we get into the fact that also using Modbus RTU, we can take advantage of some of our R70 serial data radios. So some applications you could have IO-Link sensor data that you want to send back wirelessly across your factory, thousands of feet back to an industrial controller, and then from there to your PLC or your HMI. So in this slide, what we're showing is some IO-Link sensors going back to our serial IO-Link master. So IO-Link master with Modbus RTU communications. They're going to a server radio and sending that data back across the factory to what's a client radio that you see right here. So there's a lot of cool things we could do with those serial or IO-Link masters that have Modbus RTU communications, taking advantage of the fact that we could use our serial radios to send the data back wirelessly across your factory as well. So that's kind of the portfolio. And if you have any questions on it, I highly encourage you to go to the Remote IO section of the Banner website. But the things we could do with the advanced metrics and simplified programming, it's really cool. So having logic programmed directly in the controllers, using object-oriented programming, multi-protocol, object-oriented program, script basic, action rules right there locally in these controllers. You could solve these applications standalone and replace your IPCs, replace PLCs in some of these very simple applications where PLCs might be overkill. Banner also is really starting to expand on our customization. So being able to do pin level customization. So what that means is if you need a block that has, say, IO-Link master on one port, analog input on another port, discrete IO on another port, we're really starting to do pin level or port level customization for customers. We're also looking at expanding our offering of pre-programmed units. So if you need a device for your application that has a certain programming, a certain recipe that you want to continuously order, we could work on building part numbers for that so it can make it as seamless as possible.
Mm,
Something as
nice.
easy as customizing an IP address or even having something like a program, uh, script basic program embedded in a block, we can do that. Um, Kitting is another thing where we're doing. If you want to order, say, a kit of products, whether it's an IO-Link master and several IO-Link hubs, you could absolutely do that. And we're really expanding on what we could do with customization. If you need a custom label, if you need something that has your branding or logo on the product, well, we could do that as well. So if you have any interest in what we could do with regards to pin level customization, pre-programmed units with some of those programming, advanced programming, custom ports, custom labels and kitting, feel free to reach out to us. We've got a lot of things we could do there. And I'm not sure, Shawn, if you've seen applications where, it might be beneficial in some cases for machine builders that they want to really standardize on something, just having something ordered and pre-programmed. It could eliminate some of the time factor when you're programming it yourself and just save time and a little bit of money on installation.
Yeah, no, absolutely. Especially if they're going to be using it. And I just for the audio audience, the script basic, we're looking at a little picture of it here. Standard if then and if type of syntax. So very very easy for most of us to implement. We're really talking like a basic language there. And if you had something, right, that especially people are short on staff these days. If you had a particular program that you needed for, it was so great that you guys will preload it for them and give them a special part number. That way they don't have to, you can do it right at the factory and they don't have to worry about having staff to do that. Once you come up with the program, you can order it with it preloaded. That's very cool.
Yeah, absolutely. So an example where the advanced programmability within the DXM came into play was actually here at Banner. Mike Black, who's one of our manufacturing engineers, was building a robotic adhesive application. So it's kind of in a nutshell, this small machine was being used to actually build um, Banner products. It was automatic dispensing. And so what it actually incorporated was a machine and a robot that dispenses adhesive repeatedly. Sometimes when you're doing something like dispensing an adhesive by hand, you could run into consistency issues. Robots typically are more fine-tuned, so it's going to be more consistent. So initially, he was looking at an IPC, which was several $1,000s. And when he learned about what we could do with the object-oriented programming within our DXM controllers, he's able to solve this application completely standalone um, with one of our DXM controllers with object-oriented programming, replace any need for an IPC, replace the need for a control cabinet. And in this case, he was using a lot of discrete I/O. So he actually made use of Banner's discrete I/O link hubs, bring it back to an I/O link master, and within the DXMs, within the iLink master or the DXM controller, he had his logic. And so in this case, he was able to significantly save a lot of money on this application by just that alone. But also the one thing that stood out to me is the fact that he didn't need to use a control cabinet. And there's certain things that happen when you have to, you need to use a control cabinet, and he's able to eliminate the need for that. And there's a video on this on YouTube if everyone wants to check it out on the Banner Engineering YouTube page. Another thing, when you look at our profile and talking about some of the things we could do with space saving, we've seen our IO-Link masters and devices and blocks being deployed in AGVs. We talk about the unique form factor, the fact that these are stackable, but also the fact that you're able to save a lot of space in some of these areas where space is really tight. And so AGVs has been an area we've been seeing a lot of activity on with some of our IO-Link masters in particular. And for the listen only audience, here's just an image where it shows an AGV, and we actually have an IO-Link master installed within the machine. It's kind of a cutaway drawing of an AGV showing some of our IO-Link masters and different devices going back to the IO-Link master um, on the AGV itself. Here's another application. This is at Banner. We have cooling racks, and initially it was a PLC that was controlling it, but they had different heat treating processes for Banner product, and we're actually able to do the programming within our IO-Link master to control the lights that you see on this image to give factory workers a visual element on what the status was of the cooling. So 24 hours, they would see that the light was a certain status, so green. And as time went down, it would start to change colors to give them an indication, changing from blue to green, that the process was done, that basically the cooling was completed. It's just to give workers a visual factory element to see when the cooling process was completed. Basically, how this would work is they'd load a rack, and there'd be a discrete proximity sensor that would detect the tray being loaded into the rack, and then the timer would start. So very simple logic, but in this case, PLC was being used initially, but was complete overkill. It was, very expensive, and we're actually able to save a lot of money on the fact that there's no PLC or control enclosure needed in this application right here at Banner. So just this is about 30, a 10-minute drive away from me right now, currently being used at the Banner facility. So I really appreciate the time, Shawn, on chatting with you about some of our solutions. It's been really exciting. I'm so excited to be a part of the team here at Banner and kind of working with some of these solutions. And I want to encourage the audience, if you have any questions on it, just feel free to reach out to us anytime. There's also some great content on our website on remote IO. Some of our things I've discussed today, you could find a lot more information on the products. If you go to bannerengineering.com, there's actually a whole remote IO actual topic at the very top. You'll be able to navigate to remote IO and click on all the different products that we've been discussing here today. Um, Shawn, I can't thank you enough again for taking the time to chat on remote IO. It's been always great chatting with you. Any questions from you on with regards to remote IO from Banner?
No, I think you nailed it, Shawn, and I really appreciate you coming back on the show. And very exciting product line. I'd love to hear from you guys out there listening. Are you using this, and what's your response been? Do you have an application that you're thinking of using it on? Because I'm teaching and doing these podcasts, I don't get to get out there in the field much anymore. But it looks just like, between the multifunctional or multi support for different Ethernet protocols, to the Modbus support, to the IO Link support, to the digital IO support, it just seems like you can really fit a lot of these, machine mount applications with your products, and it's a cool. And this tied in with all the other stuff we've talked about in our previous podcasts. It's definitely a great product line. So Shawn, thank you again for coming on the show. Really appreciate it.
Thank you, Shawn. I really, really appreciate it. Have a great rest of your day. Thanks again for having me on. I really, really appreciate it.
Well, I hope you enjoyed the episode, and I want to thank Shawn Foley for coming back on the show to talk to us all about Banner's remote I/O products. I think there's a great mix there between the I/O Link and the Modbus, and then the gateways to Ethernet IP, Modbus, TCP, and Profinet. So what a great compilation of different products all in one show. With that said, if you did enjoy the show, please remember to give us a like, a sub, and a share. That is the fuel that keeps this show on the air and keeps us coming back each week. And if you want to join our community, you can do so over at automation.locals.com. It's free to join. It's $2 a month if you have questions for me. And you'll also find all of my training courses over at theautomationschool.com. And with that said, I want to wish you all an awesome week ahead. Remember, no matter what happens, stay courageous, stay fearless, and try to stay positive. And until next time, my friends, peace.